Hello, this is the second part of the combinatorics unit. This is on factorials and permutations. Going pretty much right into some examples here, and then we'll talk about what each one of these is. But talked about this last time. How many ways can a teacher line up 6 students at a classroom door? So you could think of that as 1, 2, 3, 4, 5, 6 students, just like we did the fundamental counting principle. This is a dependent situation. And it's really important that when you use factorials and permutations, they are for dependent situations. Make sure that the situation is dependent. If it's not, you're just going to have to use the fundamental counting principle. So 6 students line up the door, and yesterday we did 6, 5, 4, 3, 2, 1, because each time you put a student in line, you have less to choose from. And then we could just go to Desmos, multiply that out, 6, 5, 4, 3, 2, 1. And that is 720. Well, this operation is used quite a bit in probability and in counting and stuff. If we had 20 students lined up, then we'd do 20 times 19 times 18 times 17. And it starts getting to be a long process. So in math, we can use what's called a factorial. And the way we do a factorial is if you want to do 6 times 5 times 4 all the way down to 1, it's written as 6 with this exclamation point. It's called a factorial. I'd read that as 6 factorial. And if you are on Desmos, there is right below the screen where you type in, it says main and then ABC for all the different variables, and if you want to type letters and everything. But if you go over to the function FUNC part of Desmos, you'll see it has your sine and your cosine stuff, but at the bottom is what we're going to be working with, and there is that exclamation point down there. So if you type 6, you can do that on your keyboard, or go back to your main screen and choose a 6, factorial, which is the exclamation point, and you'll see 720. It does that 6 times 5. So whatever number you do factorial, it multiplies that number times 1 less, all the way till it gets to 1. Now, if you're using the TI, I can make sure you can see the keys. The factorial is, if you press math, it's over under the probability menu, and it's number 4. So you need to do the number first, so it is 6 math over probability factorial. 6 factorial, 720. Alright, so factorials are used, like I said, when it's a dependent situation and you're putting things in a line pretty much, when you're using all of the items. All 6 students would be put in a line, so 6 factorial. Alright, so 16 teams enter a tournament. How many ways can they finish first, second, and third? So you have 16 teams, but this time you're just doing first, second, and third. Again, it's a dependent situation because whoever finishes first can't finish second, can't finish third. So that would be 16 choices for first place. Then you'd have 15, and then you would have 14. 16 times 15 times 14, done. And that would be that over there. 16 times 15 times 14, 3,360. So, how could we do that with factorials? Well, if you think about, if I did 16 factorial, that would give me 16, 15, 14, 13, 12, 11, 10, so forth, right? So this would be 16, 15, 14, 13, 12, 10, down to 2, 1. Well, I only want the 16, 15, 14, so I could divide out everything. I could, the 13, 12, 10, so forth, which would be 13 factorial. Which that would, if I divided all of that out, cancel, right? It would reduce out and you'd just be left with that. So in my calculator, if I did 16, let's make a fraction first. Alpha y equals, to make that fraction, 16 factorial over 13 factorial is the same as just doing 16 times 15 times 14. Now I think the second one is probably a lot easier, right? When you're just choosing three things. Well, this is called a permutation. And a permutation is when you're not using up all of them. You're still putting things in order, and you can use up all of them. And we can look at how that works. But you're only going to use, in this case, 3 of them, right? So we can write that in 2 different ways. You'll see it. 16p3, which means you're taking 16 teams, 16 things, and you're going to put 3 of them in order. You're going to permutate, place 3 of them in order. Sometimes you'll see it as p16.3. Now, if you go to Desmos, if you're following along in Desmos, go back to your function list, and down at the bottom there's an NPR. It'll say NPR. And when you press NPR, it brings a parenthesis up, and you just do 16, comma 3. And that would give you same number, 3360. If you're using the scientific calculator, when you go over to math and probability, it's the second one. And whether you choose it first, it'll give you the little blank. So 16 and 3. So that's the same number, again, where you're getting that 3, 3, any way we do it. And you're going to see that sometimes it's easier to use the permutation with big numbers. Sometimes it's easy just to multiply the 3 together. Factorials are always possible. So, and there's a formula. So if you think about how did I get, or why did I use 16 factorial on top and 3 factorial on the bottom when it was, or 13 factorial on the bottom when it's 16 and you're choosing 3 of them? Well, it's easy to see. So if you have NPR, well, it's easy to see the 16 came from the 16 in the front. So we're going to do N factorial on the top. But the 13 did not come from the 3. So I didn't just put the 3. So it's not R factorial on the bottom. It's because after using up the 3 numbers, there were 13 left over that I didn't want. So it's a difference, right? So on the bottom would be N minus R factorial. So that is the formula that your calculator is using. If you're asked to write it with factorials, that's the formula you would use. So for example, if you have 12p5, you could do 12 times 11 times 10 times 9 times 8. It would be the first 5. So if you write this with multiplication, it would be 12, 11, 10, 9, 8. That's one way. starting with 12, write the first 5 numbers for a permutation. Or if you're going to write it with factorials, that would be 12 factorial divided by, and then subtract them. 12 minus 5 is 7 factorial, which makes sense because 7 is the first number that we didn't use on down. That's writing it with factorials. So on the assignment, it might say write it out with multiplication or write it out with factorials, or you can just put that in your calculator. All those would give you the same results. All right. So how many arrangements of the letters simple are possible? So this is the same idea. You have 1, 2, 3, 4, 5, 6 letter word. All the letters are different. So if you are going to write that 1, 2, 3, 4, 5, 6, you'd have 6 choices, 5, 4, 3, 2, 1, or that's just a factorial. And we saw earlier, 6 factorial, 720. A 12-member planning committee must choose a chairperson, vice chairperson, accountant, and a recorder. So again, that is a dependent situation. You're not using all of them. So we can turn this into a permutation. Or you could do it like you did the fundamental counting principle. So that is, there are 12 people, and you are going to permutate 4 of them. So I can go to my calculator, and I can do 12p, and it will put the 12 there. So you can do the 12 first, or you could go over and choose the permutation, doesn't matter. So 11,880. I could have done 12, 11, 10, 9. Starting with 12, multiply the first 4 numbers. You're going to get 1180. Or if you're asked to write this with factorials, it would be 12 factorial divided by, and then 12 minus 4, 8 factorial. And if you see that one, in the 12 factorial on top, 8 factorial on the bottom, and you're going to get that same number. 3 different ways to do the same thing. Don't forget 12, 11, 10, 9. Same thing. All of them will give you the same thing. All right. So 5. Playlist, 20 songs. How many ways can you order their top 5? So again, it's always good if you're watching these notes, pause the video, try to work out this problem first. Try to do this with a permutation and see if you can do it in all 3 different ways. All right. Hopefully you got 3 different answers. So this is just 20 songs, and you're choosing the top 5, putting them in order. And that's important that you put them in order. So 20p5, I can go straight to the calculator. 20 math over to probability, number 2. 1,860,000. 1,860,480. Lots of music to choose from. Picking the top 5. A lot of different ways you could do that. Well, that's the same as 20, 19, 18, 17, 16. Starting with 20, multiply your first 5 numbers. So 20, 19, 18, 17, 16, and you get exactly the same thing. Or, if you did it with factorials, it would be 20 factorial divided by, and subtract them, 15 factorial. And you cannot reduce factorials, you cannot divide or do anything, you just have to put it in just like that. So get your fraction. If you're using Desmos with that method, you can do a fraction. If you hit the divide first, the divide sign or the slash on your keyboard for divide, it will make a fraction for you. Then on the top of the fraction, 20 factorial. On the bottom, 15 factorial. And again, same answer, whichever way. Same, I guess I'll write that out. So 1,860,480. All right. So the assignment is going over factorials and permutations. And try those. And have a great day.